So how would you calculate? How would you calculate Kc? Kc will be. Kc का formula क्या होगा? It's going to be. Kc का formula होगा. It's going to be NHC squared. So that's going to be 0.6. 1 dm cube container, so 0.6 divided by 1 squared divided by what? So divide by 0.45, जो कि N2 है, and that's power 1, and H2 that's 0.35, that's cubed. So that one is cubed. So you have a Kc expression. Anyways, I'm going to jump to Kp now. Okay, now I'll just do one Kp question and then we'll do some past paper questions related to Kp. So Kp mein what happened was you were using, that's for gases, and Kp, remember, gases के अलावा किसी के लिए नहीं हो सकता. Kp was for gases, and in Kp the idea was that जो pressure होता है ना gases का is proportional to the concentration of the gases. But you have a higher concentration, you'll obviously have more collisions. So pressure of gases, like Kp, the pressure of gases is proportional to the concentration of the gas particles. एक सेकंड ना मैं इसको रीलोड कर लूं. अच्छा ठीक है, वो समझ आ गया कि क्यों हैंग कर रहा था. वाज इन 4G. Just still stuck. 1 second. ठीक है, अब probably stuck नहीं होगा. हाँ सही, अब सही है. अच्छा, pressure of gases was proportional to the concentration of the gas particles. ठीक है, so gases के लिए pressure and concentration is directly proportional. अब इसमें Kp में एक बस extra step था. There was just one extra step, if you remember AS, and that was कि आपको ना वो करना पड़ता है. You have to calculate. The extra step is you have to calculate partial pressure. So you got to calculate partial pressure. And partial pressure was mole fraction multiplied by, it was mole fraction that was multiplied by the total pressure. Okay, so that was what the formula of so that's equal to mole fraction, or you can even use percentage. Okay, that's multiplied by the total pressure. And if you're able to find out the equilibrium moles, I mean, that's the first thing. Okay, if you have a container and you've been able to figure out the equilibrium moles. Okay, this container mein, let's say you've got N2 and H2 and NH3 reacting, and you've been able to figure out that there's these many particles of N2, like 4 particles of N2, and they're like 2 particles of H2, and you've got, let's say you've got 8 particles of NH3. 1, 2, 3, 4, 5, 6, 7, 8. तो आपको ये तो पता लग गया कि इक्विलिब्रियम पे you've got how much NH3, तो ये वाला NH3 है। जो रेड वाला है ना वो कौन सा था, that was N2, and the green one was H2, तो ये वाला जो है ना that's H2. Anyway, so once you've figured this out, you know that the total pressure that is exerted by all three gases combined, वो दिया होगा क्वेश्चन में, total pressure is let's say 2 atmospheres. Total pressure is, what is the total pressure? It's the pressure that's exerted by the H2 gas, plus it's the pressure that's exerted by the N2 gas, and plus it's the pressure that's exerted by the NH3 gas. तो तीनों का combined है, so individual pressure होगा तो it's going to be mole fraction. So if I want to figure out what is the pressure that's exerted by NH3, so that's going to be कि NH3 के particles कितने हैं? That's 8. ये total कितने थे? 8 plus 4, that's 12. 12 plus 2, that's 16. So that means, you मैंने सीखी है math नहीं, 8 plus 4 is 12. 12 plus 2 is 14. अच्छा, so 8 particles out of 14 particles belong to NH3 into total pressure, which is 2 atmospheres. Can anyone tell me what's the partial pressure of NH3? And what's going to be the partial pressure of N2 as well? That's going to be, okay, out of 14 particles, 4 of them belong to N2. And partial pressure of H2 is, ये पूरे container में you've got just 2 particles out of 14, and that's into 2 atmospheres. तो ये बता दो कि values बता दो क्या आ रही है? Anyone? Seep, Shan? Abia, what are you getting? So NSC 1.14. So this one, the next one is the 2 ATM is the total pressure exerted by all the gases combined. ठीक है, and 2.57. तो आखिरी क्या होगा? That's going to be the last one. That's 0.286. I say, anyways, I'm just going to repeat the only extra step when you're calculating KP is that you use mole fractions times total pressure. The total pressure of the container will be given once at equilibrium. All these particles will be at equilibrium, and all these particles together will be exerting the total pressure that's on the container. ये जो 2 atmosphere pressure है ना, which would be given to you, जो इस पूरे container का pressure है, that is the combined pressure exerted by N2 gas, NH3 gas, H2 gas when they collide with the walls of the container. So individually सारों का pressure क्या होगा? वो it's just going to be their fraction. Like H2 के 14 particles together, they're exerting 2 atmospheres, so 2 particles will exert how much pressure? So that's 2 14 times 2. 4 particles out of 14 will exert how much of the total pressure? That's 0.57. 8 particles out of 14. In सारों को total करोगे ना, that's going to be 2 atmospheres. So that is the only extra step. The other thing is कि आपको बस KP का जो expression है उसके अंदर you just use, instead of using concentration, you use partial pressure. So the expression would be the same. This is the Haber process reaction. So PNH3 squared and divided by pressure of N2 multiplied by the pressure due to H2, and that's cubed. तो ये values पे plug in करनी पड़ेंगी इसमें, जो अभी यहाँ पे calculate करेंगे, you would have to plug this in. So it's going to be 1.14 squared. And it's going to be bottom bit here, 0.57. times 0.286 cubed. So yeah, you'll get the Kp value this way. So that's the only extra step that would be that is needed over here, which is calculating. So the only extra step needed over here is that you have to calculate partial pressure. ये clear है? ये इसमें किया हुआ है. Is this clear? इसके हम क्वेश्चन स्टार्ट कर देते हैं. अच्छा, इसके क्वेश्चन स्टार्ट कर देते हैं कि we've got और इसके बाद we'll start with A2. ठीक है. So questions का ये तो A2 है. ES पहले रिवाइज कर लें. अच्छा, KP वर्कशीट. यहाँ पे KP है. एक सेकंड देना. Shan, A2 में basics हैं. KC KP questions. Remember the question, A2 question will be focusing on A2 stuff. So it's very rare that they ask you about directly ask about KC and KP, but remember KC and KP are like your basics. हमने A2 के अंदर ना, when we study A2, we're not going to study anything new, especially in this chapter. We'll just learn to apply KC and KP in other scenarios. उसकी applications पढ़ेंगे. So it's pretty much going to be the same thing what we're doing in AS, but applied to different things. So इसलिए वो important है कि you have to, I mean you obviously have to. जब अगले constants पढ़ेंगे ना, KW etc., it's going to be the same exact concept, nothing different. It's just going to be an application of that. तो एक आध question इसका कर लेते हैं कि this is the KP worksheet. So let's start with this one. You're supposed to calculate the value of KP. So he's saying at a total pressure of 1 atmosphere, dinitrogen tetroxide is 50% dissociated at a temperature of 60 according to the following. I said, remember, you just need to know the mole fraction, right? So let's say I start off with उसने कहा कि total pressure, dinitrogen tetroxide 50% dissociates. Let's say I start off, my initial moles are 10 moles. So dinitrogen tetroxide, and 50% dissociates. That means 5 moles are gone, 5 moles are left, right? So if 5 moles react, so दूसरी side पे जाके how many moles will they produce? They're going to produce 10 moles, right? So that is, if you start off with initial moles as 10, and you can start off with any number of moles. क्योंकि partial pressure जो है ना, that depends on mole fraction or percentage. It doesn't really depend on the actual moles. बस कंटेनर में परसेंटेज क्या है. अगर मैं स्टार्ट करता ना 100 मोल्स से, तो 50 रह जाता है, तो दूसरी साइड पे 100 बन जाते हैं. ठीक है, तो वो रेशियो फिर भी वही रहता. So it doesn't really matter what the actual number of moles is. So again, I'm going to repeat. I started off at 10 moles, a hypothetical number, 50% dissociated. So I'm left with 5. And the 5 moles that have reacted have gone to the other side. It's 1:2. So double moles ho gaye wahan pe jaake. So I've got 5 moles of this and 10 moles of this. So now the next thing is, what are the mole fractions? So total moles container mein kitne hain? That's 15. The mole fractions are calculated. What are the mole fractions? It's iski jo mole fraction hai, that's 10/15, right? And the mole fraction for this is 5/15. And how do you calculate partial pressure? What is the total pressure? The total pressure is 1 atmosphere, right? So iski contribution kya hai? That's 10/15 times 1 atmosphere. And this would be 5/15 times 1 atmosphere. ये actually 2/3 बन जाता है. and this actually becomes 1/3, right? Atmospheres. Now in the Kp expression, you use partial pressure. So I've calculated the partial pressure over here. Mole fraction, you need 10 out of total moles, that's 15. 10 out of 15, iske moles 5. 5 out of total moles, that's 15. Times total pressure. So what is the Kp expression? Kp expression is NO2, it's the pressure due to NO2 squared, or partial pressure of NO2, and that's squared, and divided by partial pressure due to N2O4. So NO2 here, that's 2/3 squared. Oh, दूसरा here, N2O4, that's 1/3. So what do I get? I get 4, और क्या होगा? 4/3. 2 squares of 4 हो गया, and I guess the 3 gets cancelled out, so it's C. अच्छा, एक और question, same one. He says 1 atmosphere pressure, that's the total pressure. 20% of the steam had been converted into, so 20% of the steam reacts. तो अगर मैं start करता हूँ 10 moles से, what is 20% of this? That's 2. पीछे कितना रह गया? 8. और वो जो 2 आगे गए ना, they'll produce 2 of these and 1 of these, right? So गौर से देखो कि initial moles were 10. 20% got converted. So out of 10, 20% are gone. वो ये बता दिया उन्होंने. तो 10 में से पीछे 8 रह गए. 20% of 10 is actually 2 moles. 2 moles react. They're going to produce 2 of this and 1 of this according to the ratio. So 2 moles of this are going to get produced and 1 mole of this is going to be produced. इसको हम direct अब mole fraction निकाल लेते हैं. What's the mole fraction of oxygen? That's 1/11, I think. 1/11 है. So what is the mole fraction of this thing? Total moles are 11 now. It's going to be 2/11, this one, mole fraction. अब इसकी mole fraction क्या है? That's 8/11. What is the total pressure? That's 1. What is the total pressure? 1 atmosphere, और इसका भी 1 है. So which answer is the correct one? The correct answer जो होगा ना, that's going to be D. Okay, 8/11 is basically 0.8/1.1. That's the same thing. 2/11 is 0.2/1.1. Or 1/11 is 0.1/1.1. ठीक है, तो ये आपके partial pressures आ गए. Is this clear? ये तो ATM में लगा देते हैं. ये clear है? अच्छा, अगला part के बस सिर्फ KP वाली questions. Remember, only temperature changes KP. Ajay, just KP questions directly. Ajay, this one. So here's a gas, and again it's a similar question. Okay, there are 2 moles initially of this thing. तो भी शुरू मैंने इसके 2 moles ऐड किए हैं. अच्छा नहीं, सॉरी, डाइनाइट्रोजन टेट्राऑक्साइड 2 moles इसके ऐड किए हैं, इसके नहीं ऐड किए. So they added 2 moles of this. And after equilibrium had been established, the total pressure was 140 kilopascals, and the mixture of gases contained 1.84 moles of dinitrogen tetroxide. So he's saying that अब जो है ना वो 2 moles दिए हैं, अब है 1.84 at equilibrium, right? So it contains 1.84 moles of dinitrogen. So what happened to the 0.16 moles? 0.16 moles गायब हो गए. So they've I mean, they must have been used up and they must have reacted and they must have produced NO2, right? So you started off with 2, you're now left with 1.84. So 0.16 are gone. So if 0.16 are gone, तो वहां जाके double बनाएंगे. It's going to be 0.32 moles. Is this clear? और अगला पार्ट है कि मोल फ्रैक्शन निकालो. जब आपको पता लग गया कि you've got 1.84 moles of this and you've got 0.32 moles of this in the container. So you have to figure out the mole fraction. So we'll do that. Mole fraction क्या होगी? That's 1.84 divided by the total, which is कितने moles हैं? 1.84 में 0.32 add करो. What do you get? 210 हो गए और 16 is it 2.16? 2.16, that's the total moles. उसके निकालोगे mole fraction, that's going to be 0.32 out of the total, which is 2.16 again. So ये mole fraction आ गई. Mole fraction should be multiplied by the total pressure, which is 140 kilopascals. उसको भी जाके multiply कर दो 140 kPa से. So you found, तो बाकी सारे steps हमने कर लिए. Calculate the number of moles, hence the mole fraction, और फिर end में जाके he's asking के calculate the value of Kp. So what you're going to do is you're going to plug all of this in Kp. Kp क्या था? That's product N2O4 का pressure divided by NO2 pressure, that was squared. तो बस इसको solve करो. ये 1.84 times 140 kPa divided by 2.16, and the whole thing gets divided by NO2 squared. So that's 140 multiplied by 0.32 divided by 2.16, and that's going to be squared. तो आपका आंसर जो है ना वो आ जाएगा. एक आध और क्वेश्चन कर लेते हैं कि अच्छा पिछला क्वेश्चन क्लियर था? दिस वन इज दिस क्लियर? अच्छा एक और अगर जल्दी से कर लें. ये sulfur dioxide वाला equilibrium है, so it's kind of the same thing. You've got sulfur dioxide reacting. You must have given the reaction somewhere. No, actually you didn't. खुद ही लिख लेते हैं. Sulfur dioxide reacting and producing sulfur trioxide. So he said that 2 moles of the two things were mixed together initially. 2 moles of SO2 and 2 moles of oxygen. They were left in a flask and left to reach equilibrium. A pressure total ये था, and the mixture contained 1.8 moles of sulfur trioxide. So now instead of 2 moles, it's got 1.8 moles. इसका मतलब है 0.2 reacted, right? So that means 0.2 are gone. Now 0.2 reacts with its 2:1, so 0.1 of this will also be gone. So it's 2:1, the reactant 2:1. So if 0.2 are reacting, so they would react with 0.1. So 2 में से ना 0.1 are gone, so you're left with 1.9 moles. And 0.2 reacts with 0.1 to produce 0.2. So यहाँ पे ना there's going to be an extra 0.2 getting produced. So you'll have 0.2. बल्कि मैंने गलत कर लिया question. वो sulfur trioxide की बात कर रहा था. This is, all of this has to be redone. ये नहीं है question है कि he's saying that 1.8 moles of sulfur. So initially you had 0 moles, right? But now you don't have 0 moles. You're at equilibrium, you've got 1.8 moles of this. So that means an extra 1.8 moles got produced, right? Because you started off with 0. Now you don't have 0, you've got 1.8. So 1.8 बनाने के लिए इधर कितना react होगा? It's 2:1. So 0.9 must have reacted. And to form 1.8, it's 2:2. So 1.8 over here must have reacted. So your equilibrium moles over here will be 0.2. Because 2 moles there, 1.8 are gone. So that you're left with 0.2. 2 moles there, 0.9 are gone. So that you're left with 1.1 moles. ठीक है, तो उससे कहे कि ये start था, this is your initial. So that were your initial moles, or end में 1.8 इसके पड़े हुए थे. So that means 1.8 extra got produced. And 2:1, so 0.9 over here must have reacted, and 2:2, so 1.8 over here must have reacted. तो वो कम कर लिए. अब इसकी mole fraction यही निकाल रहे हैं. Mole fraction क्या होगा? It's going to be its moles divided by the total moles, which are what? 3.1. Total moles कितने हैं? That's ये वाले moles तो खत्म हो गए. It's 1.8, 1.1, that's 2.9, 0.2, that's 3.1. So the mole fraction is divided by 3.1 multiplied by the total pressure. The total pressure is, उसको मैं P कर देता हूँ. ऊपर वैल्यू दी हुई है, ठीक है. I just don't have space to write over here. तो end में KP निकल आएगा. Is that clear? कि KP के questions होंगे, just practice. This is all old AS stuff. ठीक है, बस KP में आपको partial pressure निकालना पड़ता है. And how do you find, once you find the moles at equilibrium, you just multiply by total pressure. अच्छा, ये सारा clear है? ताकि हम actual topic start करें. Is this clear? सारा AS था, ठीक है? Yes or no? Is this clear? Tabia, Anna, Alicia. अच्छा, अब A2 के अंदर what you'll have is just applications of equilibrium constants. So we're going to start with the first basic one, which is, अच्छा थोड़ा सा मैं वो idea देता हूँ acids. Now a lot of this would be applied to acids and bases. So we're going to start off with Kw and acids and bases. Now that's known as a ionic product of water, or a water constant. Or the water constant. And it's an equilibrium constant. I mean, it's Kc. It's nothing. There's no difference. It's exactly Kc. They can apply to, well, constant exactly Kc wala applied to a certain scenario. So what is Kw? Before understanding what Kw is, here's what happens. That, remember, water is the most important chemical because it's everywhere, and all solutions, most solutions, 99.99 times out of 100, most solutions anywhere on this planet are basically water-based. These molecules, if they're reacting, if molecule A and molecule B are reacting, so they're reacting in a solution, they're able to float around, they're able to collide because they are present in water. ठीक है, water के अंदर वो present है, and they're moving around in water. So all these particles are floating around in water, right? So what is important now? What happens with water is, कि water has an equilibrium. कि water का molecule अगर देखो ना, it's going to have 2 hydrogens attached to it, And let's say there's another water molecule, and that's going to have exactly the same scenario, that it's going to be O. उसके साथ में there's going to be two hydrogens that will be attached to it. Now, water is a highly polar molecule, so it's got these strong high charge density lone pairs. It's got a very strong partial positive क्योंकि वो oxygen के साथ bonded है, and the lone pairs have a significant negative charge. The same applies to the other water molecule, that it's got its lone pair's got this negative charge, and the H is highly positive. अच्छा, अब होगा ये कि when water molecules, when you have lots of water molecules, right? So imagine you've got lots and lots of water molecules. So what will happen is they will react with each other. तो इसका जो lone pair होगा ना, that is sometimes, very rarely, ठीक है, not very often. The water molecules they don't ionize a lot. So this is not, so this H over here, its lone pair is going to attract this H, and it will eventually form a dative bond. So a reaction will happen. If the molecules collide with sufficient force, तो उसका H जो है ना, it's going to get attracted to the lone pairs over here, and this is what the result is going to be. Okay, I'm going to do the whole working over here. So this H breaks off from here. It loses its electrons in the process, and it travels to the lone pairs, gets attracted to it, and ends up forming a dative bond with it. So there's going to be, so there's going to be a dative bond that is going to be formed. ठीक है, so गलत वाले पे कर लिए, इसको इधर करना था. अच्छा, और वो जो H है ना, that has left its electrons over there, so that oxygen, अच्छा, this oxygen over here is now going to have a -1 charge. It's actually OH -1. तो आपके पास क्या बन रहा है? You're getting OH -1, and this one is known as H3O +1. And this is an equilibrium reaction. Like, the reverse can also happen. So this reaction is equilibrium. The opposite can also happen. The H can leave the lone pairs and get attracted to the oxygen back again, and it will form the two water molecules back again. So there's this reaction that's going on. उसको word equation में लिख लेते हैं कि that's water reacting with another water molecule. And when they do that, they have a reversible reaction, और उस reversible reaction में what is getting produced? It's OH ions and H3O +1. Okay, that's the reversible reaction that exists in water. Is this clear? Okay, ये clear है सारों को? सारों clear? उमर, शाहान, नसीब, मनीषा, Anna. अच्छा, तो ठीक है, ये हो रहा है. अच्छा, remember, ये बहुत ज़्यादा नहीं हो रहा, ठीक है? It's just that when you have water, when you have a solution that's made up of water, अच्छा, remember, water is everywhere. We are made up of mostly water, ठीक है? All our cells, all our blood, etc., everything. There's water, plants, everything is water, ठीक है? So this is happening everywhere on planet Earth. लेकिन ये जो ionization है, that doesn't happen a lot. Like the amount of ions at equilibrium are very few. बहुत ही कम है. That's the concentration of OH ions is 1 times 10 to the power minus 7 mole per dm cube. And the concentration of HCO plus 1 would be exactly the same because it's 1:1. So now 1.10 raised to the power minus 7 mole per dm cube is a very, very tiny concentration. So that means the reaction is completely favoring the reactants. It's not even moving towards the product, and it's happening very little. So very, very weak. This indicates that you got very weak ionization. As I use values, these values are only applicable to RTP. It's only for room temperature and pressure or standard conditions. Let's call it standard conditions. So the reaction kind of speeds up. If you heat at higher temperatures, there's more ionization. So the concentration is expected to be higher at higher temperatures. So now there's an equivalent reaction for this as well. And that reaction is, okay, this HCO plus 1, this is known as the hydronium ion. That's known as the hydronium ion. Now there's an equivalent reaction, a simplified version of this, and that is, जो आप ओलव्स में लिखते थे कि water ionizes and it forms two ions. One of them is H plus 1, the other one is OH minus 1, right? So there's an equivalent simplified version of the same reaction, which is this. So the hydronium ion is actually the thing that you call H plus 1 aqueous. Because H plus 1 that's never actually going to be aqueous, because H plus 1 that will, if you add H plus 1 to water, the H plus 1 will get attracted to the lone pairs of water. So pani ke andar that you don't actually have H plus 1 ions. What you have is hydronium ion. So this is an equivalent simplified version of the same reaction. So H plus 1 aqueous जैसे आप कहते थे ना, that from now on is actually HCO plus 1 aqueous. That's your hydronium ion. But you can still call it H plus 1 aqueous. It doesn't really make a difference. क्या आप उसको अभी भी वही कह सकते हो? बल्कि we will actually call it H plus 1 aqueous. Because it doesn't really matter whether you call it H plus 1 aqueous or HCO plus 1 aqueous. Just remember this fact. Okay, pani के अंदर actually H plus 1 exist नहीं करता. The H plus 1 quickly goes, bonds with the lone pairs in water, and it ends up forming HCO plus 1. So these are your equilibriums. Both of them are exactly kind of the same. मैंने concentration भी बता दी है कि the ions will be produced in this quantity at under standard conditions at 25 degrees centigrade. ज़्यादा temperature होगा, there's going to be more ionization. They'll bump into each other a lot more if they have higher kinetic energy, which would result in more ions getting formed. So ये clear? ये वाला part clear? Is this clear? कि water की ionization, is this part clear? और मैं इनमें वो बता दूं कि अच्छा OH after negative charge on OH is going to be कि ये जो H नहीं है वो अपने electrons पीछे छोड़ गया. I mean, when the lone pairs, the negative lone pairs were attracting the H, they were repelling the electrons over here. तो वो अपना एक extra electron ना पीछे छोड़ गया. That's why it's OH minus 1. And that's why the other one is positive, because the H positive ion went and got attracted. ठीक है? तो इस वजह से चलो बाकी काम वो फिर नेक्स्ट टाइम करेंगे कि KW क्या है. KW कुछ नहीं है, इट्स जस्ट इक्विलिब्रियम कांस्टेंट ऑफ दिस रिएक्शन. इट्स अ रिवर्सिबल रिएक्शन. तो इसका जो KC है that's KW. So we'll talk about KW next time. It's just products concentration divided by reactants concentration, exactly KC that you did. So KW is basically KC applied to either this reaction or this reaction. Both of them are kind of the same reaction. ठीक है, लेकिन we'll talk about KW in the next class. चलो ठीक है, ओके एवरीवन, कल होगी क्लास. ठीक है, तो कल डिस्कस करते हैं. ठीक है, अल्लाह हाफिज.